Hi, welcome to the channel. I'm Justin, and I'm going to show you how I'm using GDB to attach to a QEMU session. So I normally use GDB in my C++ workflow, but you can see here, this is for an embedded systems course that I'm working on, and I'm not normally this close to the hardware, even though I do work on C++ algorithms for what's ultimately embedded algorithms, but this is my first foray into assembly. So if you got any tips and tricks for QEMU or going through this debugging process, let me know down in the comments. So first up, we're going to use, this is in my bash RC. I just made this function, make it easy for me because I'm anticipating doing this operation quite a few times. So we're going to use QEMU-system-arm to start a QEMU session-m on this machine. If we do QEMU system arm-machine help, what we're going to get is a list of machines that's available. And so if we search for that machine, we'll see that this is a Cortex M3 device. Dash kernel, this is the program. We're going to need no graphics. I like just using the terminal -s. This is going to tell QEMU to wait for us to attach with a GDB session. We're going to attach with GDB at this port 1234. So we'll just pass in this the program as the program file as the argument. No solutions here. This is just an example that was provided, and we're going to step through it. Simple counter program. So I'm going to use this GDB multi-arch, and we're going to use this this option -TUI, and this is this text user interface, and it's going to give us a few more options on how to visualize where we are and what is happening in the program. So when this starts up, we're going to get our normal kind of line view of the program in this init.s source file. So we're going to say target remote localhost 1234, and this is where we told QEMU that we're going to attach. So now you can see we're attached and stopped at line 21, and you can see the command highlighted there. So one thing that we can do is we can say layout split, and this is going to show us the instructions of the program here in order, and on the top it's going to show the source code. And as we step through, it's going to highlight what is happening, and so we can see that. Now what we can do is layout reg, and we can see all the registers, and it's nice because we can see the hex, and we get all the information up here. And then what's really nice is as we're stepping, it's highlighting what we're doing. And then if we want to see what the source code looks like instead of this instruction view, we can just type L, and we get the normal lines in this split, and it's telling us what file we're in. So we can keep stepping as for step the instructions. So now we've branched with link, and we can see the link register updates, and the next thing we're going to do is we're going to push R1 to the stack. We see that register has updated, and then we're going to load into R1, and we're going to add R0 and R1, storing the result in R0. Then we're going to pop from the stack back to R1, and and restore that value. Then we're going to return to where we branched from, and then this is just a branch back to the top of the counter, and we will go through and continue to add R1 to R0 and storing the result in R0. Thanks for watching. Let me know if this helped, and let me know if you have any tips and tricks for me for how you're running QEMU or GDB or any other debugger to debug your assembly. Thanks again.